Under what conditions does nitrate-rich beetroot supplementation have the greatest performance-enhancing effects? Welcome to the Science of Getting Faster podcast, where we cut through the headlines, talk directly to the researchers to find out what their studies suggest, what they don't, and where their research is heading. With us on the podcast today, we have Dr. Stephen Bailey. Thanks for coming on the podcast.
Thank you for having me, Sarah.
Yeah, it's our pleasure. And today we're going to be discussing your paper, The Influence of Muscle Oxygenation and Nitrate-Rich Beetroot Juice Supplementation on Oxygen Uptake Kinetics and Exercise Tolerance. Could you start by explaining what are nitrates?
Okay, so there's two forms of nitrates. There's the organic nitrates that are synthetic compounds that are used to treat cardiovascular diseases. And we're not going to talk about them in today's podcast. Instead, what we're going to focus on is the form of nitrate that's abundant in foods. So we have nitrate that's present in certain foods, particularly green leafy vegetables and beetroot. So nitrates are produced in these particular plants, and then they are obviously consumed by us as humans. And over the last few years, it's been emerged that if you consume these as part of a healthy, balanced diet, then you can start to see some beneficial effects on various aspects of physiology and also some aspects of exercise performance as well.
And are beetroots the food highest in nitrates, or are they just simply the easiest to concentrate into a juice?
Yeah, that's a good question, but also quite a difficult question to answer because it really depends on a number of factors in terms of how the vegetable of interest is grown. So, for example, if you look at some of the very first beetroot studies that were done, they weren't grown in organic conditions, so they used nitrate-based fertilizers. So they actually had a lot higher nitrate content than more up-to-date methods now, which seems to move towards more organic farming practices. So beetroots are a very high source of nitrate, and also that if you use a certain supplement product, they can be quite consistent. Other options, as I mentioned, were green leafy vegetables. So certain types of lettuces, in particular rocket or arugula for your American listeners, cress, spinach, radishes are quite high in nitrate as well. So green leafy vegetables, things that often go in salads, are particularly high in nitrate. There's also some nitrate that's found in cured meats as well, so hams, sausages, and so on. So you'll also find a little bit there as well. But green leafy vegetables make up the majority of dietary nitrate intake.
Okay, and do the nitrates have a direct impact on our physiology, or are they converted into something that then has an impact?
It is believed that nitrate is relatively biologically inert. We can't rule out for sure that they don't have any physiological role, but it is largely believed that after consuming nitrate, it's not the nitrate per se that has the effect, but it's the subsequent reduction, the chemical reduction of nitrate down into nitrite, and then more likely the subsequent reduction of nitrite down into nitric oxide and other reactive nitrogen intermediates. This is believed to bring about the positive effects of dietary nitrate supplementation.
Where does those reduction processes, where do they occur?
Okay, yeah, so once we've consumed nitrate in the form of a dietary form, it obviously passes down into the stomach, through the intestines, then into the circulation. And then once the nitrate-rich blood passes through the salivary glands actively uptake nitrate. This nitrate is then secreted into the oral cavity. And there on the surface of the tongue, we actually have a number of anaerobic bacteria, which actually can reduce the nitrate down into nitrite. This nitrite is then swallowed. A large portion of this is reduced into nitric oxide in the stomach, and also into other important reactive nitrogen intermediates. But it's also clear that some of this nitrite will then pass into the bloodstream and can be reduced down further into nitric oxide. In addition to this pathway, the recent evidence suggests that actually there might be a significant role for the skeletal muscle. So it was until quite recently, it was assumed that it's only the oral bacteria in the mouth that could reduce nitrate down into nitrite for us. But it's recently been shown that the enzyme xanthine oxidase, which is abundant in human skeletal muscle, can actually reduce nitrate down into nitrite and also nitrite down into nitric oxide. So those are the two pathways that we can use essentially to produce nitrite and subsequently nitric oxide after we've consumed a diet enriched with nitrate.
Does nitrite have an impact? Can that have a direct impact on our physiology, or does it have to go through that process of converting or reducing into nitric oxide?
Yeah, again, the data on that is not entirely conclusive, but there is some evidence to suggest that nitrite might have a direct effect on certain proteins and might change their function. So it can cause something called S-nitrosylation, which is where you can change the activity of a protein, for example. So there is some evidence to suggest that nitrite could be involved in changing certain physiological processes, but equally there's some evidence to suggest that it's more a biomarker of nitric oxide and not really a signaling molecule in its own right. So the jury is very much out on that.
Fascinating. So nitric oxide is the signaling molecule that we're primarily interested in having performance-enhancing effects.
Yes, that's considered to be the principal mechanism by which nitrate supplementation is going to bring about its physiological effects. So it's the reduction of nitrite down subsequently into nitric oxide that is believed to bring about the majority of the effects. And that makes sense because we know some of the physiological responses that are regulated by nitric oxide.
And what are those effects?
Well, nitric oxide is a multifaceted physiological signaling molecule, so it can impact quite an array of physiological processes. So as some examples that might be most relevant in an exercise context, the classical way that NO has been brought to bring about physiological effects is to serve as a relaxer of the smooth muscle cells in the blood vessels. And this can bring about vasodilation, which is where we open up the blood vessels and can deliver more blood and therefore oxygen and other nutrients down to the tissue. And that might also have a role for causing the removal of potential byproducts from the tissue. It's also got clear metabolic effects. So nitric oxide is recognized to have a role in, for example, glucose uptake into muscle tissue. It's recognized to have effects on the mitochondria. So these are the powerhouses of the cell, which are responsible for resynthesizing ATP, which is our main source of energy for performing muscular contractions. Nitric oxide also has quite an effect on muscle contractile processes themselves. So it can influence the release of calcium into the cytosol, which is a key event that brings about muscle contraction. It can also impact the muscle contractile apparatus themselves, so actin and myosin. And there's obviously various other processes, neurotransmission, but that just hopefully gives you a little bit of flavor. But NO is involved in a myriad of physiological processes.
Wow, yeah, so in that way, it's very clear why we're interested in finding out how we can maximize those effects. And are there conditions then that promote that reduction process from nitrates to nitrites to nitric oxide?
Yeah, absolutely. So what we seem to know about the metabolic pathway and specifically the reduction of nitrite down into nitric oxide is this reaction needs a proton. So therefore it's favored in conditions of acidosis. We also know that obviously acidosis is more likely to develop in conditions of lower oxygen tensions. So what we know is that the reduction of nitrite into nitric oxide seems to be enhanced in conditions of lower pH or acidosis and conditions of lower oxygen content within blood vessels and within tissues. So those seem to be the conditions that are quite effective at stimulating the reduction of nitrite into nitric oxide. And that's also quite useful from an exercise perspective because we know that in the muscle tissues and in the microvasculature, the little blood vessels that surround the muscle, we know that particularly during higher intensities of exercise, then pH will decline and the oxygen tension will also decline. So that gives us a ripe environment, if you like, for the nitrite to be reduced down into nitric oxide.
Yeah, and that leads us then to your question. What was the question you had going into the study?
So yeah, the purpose of the paper that we conducted and that we're discussing today is we really wanted to try and manipulate the oxygenation of the skeletal muscle to see whether we would observe greater effects with nitrate supplementation when we lowered the muscle oxygenation, and equally whether the effects would be attenuated when we increased muscle oxygenation. And so to test this, what we did is we manipulated the concentration of oxygen that people were inhaling. So typically the air around us has 20.9% oxygen. So we lowered this to a bit less than 15% oxygen in the low oxygen condition, and we increased this to 40% oxygen in the high oxygen condition. And if we just define those, we have normoxia, as I said, around about 20.9% oxygen, hypoxia, so hypo means low, lower oxygen concentration, and then we have hyperoxia, where we increase the oxygen concentration. So those were the conditions that we had, and obviously we completed those conditions with the beetroot juice supplement, and also then we had the same beetroot, but it had the nitrate extracted from it. So those were the experimental conditions that we tested in this paper.
And how do you extract the nitrates from the beetroot juice in the placebo?
So in the particular supplement that we used in this study, the Beetroot Sport, the way that you extract the nitrate from the beetroot is you pass it through a specific resin, which is purolite. And what that will do, it's a specific resin which will extract nitrate ions. And so what you're left with is beetroot juice that is essentially the same in terms of appearance and taste, and has the other nutrients that are present in beetroot juice, because we can't exclude the possibility that there might be some other nutrients there that could have some effects. And essentially what you have then is a very true placebo, which is essentially the same product but devoid of nitrate.
Okay, and so in those different oxygen concentrations, you weren't going up in elevation, you were just manipulating the environment. So if the air pressure was the same, would that still have the same? Do you expect that to have the same effect as, say, if we were going up in elevation to the same oxygen concentration?
Yeah, so that's an important distinction to make there. So there's different ways you can lower the oxygen tension that someone is exposed to. So what we do is we didn't change the barometric pressure, as you said. We stayed at sea level for all of these experiments. And instead what we did is we changed the concentration of oxygen that was in the gas that the individuals were inhaling. The other way you can do that is you keep the percentage of oxygen the same, but you lower the barometric pressure by going up altitude. So essentially, if you go up to higher altitudes, the percentage of oxygen stays the same, but the barometric pressure comes down. And what sets the partial pressure of oxygen is the percentage of the gas multiplied by the barometric pressure. And that's important because the way that oxygen moves into the lungs and from the lungs into the blood is across a pressure gradient. So it's actually the total partial pressure of oxygen that's important in terms of the diffusion of oxygen from the atmosphere into the lungs, and equally from the lungs into the blood, and then from the blood into the muscle itself. So we used normobaric hypoxia, which is where we didn't change the pressure, but we lowered the percentage of oxygen in the gas mixture. And to answer your question around should that elicit similar effects, we would imagine so, because the net effect on the partial pressure of oxygen should be similar whether you go up a mountain to achieve it or whether you stay at sea level and lower the percentage of oxygen.
Okay, and so the variables then you were manipulating, as you said, were oxygen concentration and exercise intensity and the beetroot supplementation or placebo. What were then the variables or the outcomes you were measuring that you expected to have an impact on?
Yeah, so we looked at a number of physiological and performance outcome variable. So if we think of the physiological variables, we were interested in the plasma nitrite concentration, not just at rest, but also during exercise to see what happened to that. We were also interested in the muscle oxygenation itself, not just to confirm that the intervention had changed this, but also whether the nitrate intervention could actually impact on this. And we were also interested in the pulmonary gas exchange responses. So we could look at the oxygen cost of exercise, the VO2 peak, and also some of the oxygen uptake kinetic variables. And finally, we had the individuals complete a severe intensity exercise task to the limit of tolerance, which gave us a marker of endurance exercise performance.
Okay. You said that you measured nitrite concentration.
Yes.
Why would you measure that as opposed to nitric oxide in the blood?
Yeah, that's a good question. And if we could measure that very easily, we would. But the problem with nitric oxide is it's a free radical, which means it has an extremely rapid half-life. And particularly in human tissues and blood, it's got a half-life of less than a second. So you cannot measure this in vivo, so in the body directly in humans. So we have to rely on surrogate markers. And essentially, nitric oxide gets oxidized into nitrite and into nitrate. And these are more than stable biomarkers of nitric oxide. So that's why we need to measure them as more stable markers of NO.
Okay. And the VO2 uptake kinetics, what does that mean really? What are we measuring here?
So there's various variables when you measure gas exchange. So if you measure gas exchange on a breath by breath basis and you have an individual perform step increments in work rate. So if you go from a very low intensity on a cycle ergometer, so just say 20 watts just to turn the legs around. And then if you increase the work rate immediately to higher intensities, what you'll see is an exponential increase in oxygen uptake. Now, depending on the intensity that the individual is exercising at, this will influence the shape of the response, essentially. If we're dealing with quite low intensity of exercise, so below someone's lactate threshold, what you'll see is in most healthy individuals, the oxygen uptake will increase exponentially and will reach a steady state within 2 to 3 minutes. When we deal with individuals going to higher exercise intensities, what you'll have is that a similar response to what I've just seen explained to you now. Obviously, it'll be a bit higher because the work rate is higher. But essentially what will happen then is the oxygen uptake won't reach a steady state. It will continue to increase with time. And if the exercise intensity is of a sufficient intensity, particularly if it's above someone's critical power, I'm not sure if you've done anything on that with your podcasts, what you'll find is the oxygen uptake cannot attain a steady state. Essentially, what will happen is the oxygen uptake will continue to increase with time until the VO2 peak is attained. So in this particular study, we had individuals perform an initial step test to a low intensity work rate, and then they transitioned immediately into a severe intensity work rate, which they continued until exhaustion. And interestingly, what you can do is you can fit an exponential model to that to see how quickly oxygen uptake increases to these step increments in work rate. And doing a severe intensity exercise bout that's continued to exhaustion, if you look at the average VO2 over the last 20 or 30 seconds, that should give you an estimate of someone's VO2 max. So we also were able to extract that from this exercise test battery that we used in the current study.
So the goal during exercise is that we want to consume as much oxygen as we can. That would be a positive thing. So that would be our peak VO2 max. Is that correct?
That really depends on the intensity of exercise and what the nature of the exercise is. So for example, if you're dealing with a marathon runner or a long distance endurance athlete, what you want is kind of the opposite of what you've just said. You want their oxygen cost to be lower because that would suggest that they're more efficient. And we know, for example, with marathon runners, that it seems that things like running economy is far more important than VO2 max for those individuals. So it really depends on the athlete. With higher intensity of exercise, then yes, what you want to do is over the initial stages of exercise, you want to try and consume quite a lot of oxygen, because what that might do is spare the utilization of the anaerobic energy reserves, because we know that they're quite limited. And also if you have a higher proportional contribution from oxidative metabolism, then that should in theory lead to a lower proportional contribution from anaerobic metabolism. And during high intensity endurance exercise, excessive reliance on anaerobic metabolism is going to lead to premature fatigue. So right. It really depends on the intensity of the exercise, whether consuming more or less oxygen is a good thing or not.
Which is why we'll get into this. You've got the two intensities that you look at, and you're determining their economy, like you mentioned. Can we minimize the amount of oxygen, or minimize the amount of oxygen we need at that given intensity, and then we go into severe to see what's the maximum we can intake. Is that correct?
Yeah, no, absolutely. So if I talk about initially the kind of effect of nitrate that's been generally observed in the field, and then I can talk specifically about what we saw in this particular study that we're discussing in today's podcast. So generally speaking, nitrate supplementation, if we're dealing with young, healthy individuals and it's being given at a sufficient dose, has the potential to lower the oxygen cost of low intensity exercise. So I'm talking about exercise below the lactate threshold. So this is typically the intensity that most people would run a marathon at, for example. So quite low intensity exercise that can be sustained for several hours. The literature does seem to suggest it's not observed in all studies, but in the meta-analyses that have been published, there is evidence to suggest that nitrate supplementation overall can lower the oxygen cost of exercise. Again, at least in recreationally active individuals. This effect seems to be lost as you go to better trained individuals. But this effect is quite small. So you're only looking at maybe a 2 to 3% reduction in the oxygen cost of exercise. Now, one of the things that's needed, and there's quite a nice paper that came out recently by Rachel Tan, who was part of Andy Jones's research team, where they showed that if you want to be able to detect this effect, what you need to be able to do is to perform repeated steps to that moderate intensity. And then what you can do is you can average the data responses. Because one of the problems when you collect breath by breath gas exchange data is there's a lot of noise in the signal. And unless you perform repeated transitions to smooth out that noise, then it becomes difficult to detect that effect. And that is one of the limitations of the study that we're discussing today. We didn't observe a change in the oxygen cost of low intensity exercise. And one of the reasons for that, of course, there could have been no effect in the participants that we tested, but equally, we only performed one transition, exercise step transition to the low intensity work rate. So we might not have had sufficient sensitivity with our measures to be able to detect that 2 to 3% difference that we might have seen with the beetroot juice supplement.
Okay, so yeah, let's get into the study. What was your hypothesis then for the various outcomes?
Yeah, so the hypotheses that we had in this particular study was that dietary nitrate supplementation would improve performance, defined as the time to exhaustion during the severe intensity exercise in normoxia, as has been shown in previous studies, that this effect would be enhanced when we had the individuals exercise in hypoxia, and that this effect would be impaired when we had individuals exercise in hyperoxia. And all of this was underpinned by that rationale that the reduction of nitrite into nitric oxide seems to be enhanced in conditions of lower oxygen tension and pH, and might be interfered with when oxygen tension and pH is higher. So that was the hypotheses, and that was the theoretical basis to underpin those hypotheses.
Definitely. And who were these participants in your study?
So in this particular study, we had 10 healthy, recreationally active males. So they had I can't remember off the top of my head what their group mean VO2 peak was, but it was in the healthy to fit range. I'd imagine it was in.
I think it was 49.
That sounds about right.
5.
Most of the studies that we've done with this type of population group is in the region of 45 to 50 mils per kg per minute for a VO2 peak. So far fitter than your average individual, but not above 60, which would be needed to be classified as well trained from an endurance perspective.
And this is important because, as you mentioned, there might be differences between elite athletes, well-trained athletes, and untrained athletes. So something to consider, I suppose, when we're interpreting the results.
Oh yeah, absolutely. There's some nice data out there suggesting that depending on your aerobic fitness, if you take VO2 peak as a guide on that, the potential for beetroot juice to be performance enhancing is greater in those individuals who have a lower VO2 peak and is smaller in those individuals that have a higher VO2 peak. There are some studies where they've done work with quite high caliber athletes, and they've seen on the group mean level no significant improvements in performance. But equally within those samples, you will see maybe 1 or 2 individuals who do report a practically meaningful improvement in performance. But across the board, the more aerobically fit an individual becomes, the lower incidence of a positive effect of beetroot juice on their performance. It doesn't seem to make things worse, but its potential to bring about meaningful positive effects becomes less frequent as we deal with better trained endurance individuals.
Do you think that's partly because it's harder to detect meaningful, like at that top level, it's a smaller increase that's required to have effects?
There's a balance there between significance from a statistical standpoint and from a practical standpoint. And yes, it might be more difficult to detect the very small, meaningful performance outcomes in those individuals. But equally, if we think from a metabolic standpoint, what we've talked about so far is that the reduction of nitrite into nitric oxide seems to favor a scenario where we have lower oxygen tensions and lower pH. Now, one of the things that characterizes high caliber endurance athletes is they have a better capability to better oxygenate the muscle and also to maintain the pH balance in the muscle a little bit more effectively. So that might account for some of the lesser effects that those individuals observe. There's also some suggestion that nitrate supplementation, and again, this links to that pH oxygenation story. It seems to be that individuals who maybe have more fast-twitch fibers might respond a little bit more effectively, and conversely, those who have more slow-twitch fibers, which would be what would be necessary to be a high-calorie endurance athlete, would perform a little bit less effectively to nitrate supplementation. So it's a combination of the fiber type, the sensitivity of the performance tests that might be underpinning the lack of such a magnitude of improvement in better trained endurance individuals.
Fascinating, and it also reinforces the importance of this study, looking at what conditions might affect that. So your participants, they came in on 9 different occasions, the first being for their baseline testing. What is the purpose of this, and what did that involve?
So the first test that we do in a lot of our studies where we do some kind of endurance performance outcome is we perform some type of incremental test. And this is necessary because what we can do with this is firstly characterize their VO2 peak. So it gives us a handle on their fitness status, whether they meet their inclusion criteria. So for example, if we were looking to exclude highly trained individuals, we would say if their VO2 peak is over 60, then we'll exclude them from this study. Or equally, if we were saying we want them to have a VO2 peak above 35 mils per kg per minute, then we'd exclude them if they were below this. So it allows you to measure the VO2 peak. It also allows you to measure other physiological thresholds, principally the gas exchange threshold. And what you can then do once you know these is you can set the intensities for the main experimental trials relative to these thresholds. So the low intensity exercise, I believe, was at 90% of the gas exchange threshold in this study. And what we then did is we looked at the difference between the gas exchange threshold and the peak power they attained in this test. And we took 70% of that difference. Now, the reason for that is that the critical power in most moderately trained individuals is going to be in the region of probably 40 to 55% delta. So we went with 70% delta to ensure that the individual should have been in the severe exercise intensity domain. So we wanted to make sure that individuals were placed into the exercise intensities that would give consistent responses through the study.
And what, if we were to relate this to just RPE, say perceived exertion, what would that moderate intensity feel like?
So if we're thinking of the 6 to 20 scale, I don't do so much with RPE anymore, but I think that you'd be looking at 8s and 9s for the lower intensity, and it would be stable. The challenge with severe exercise is that the RPE won't stay consistent. It will increase with time. So it might start off in the first couple of minutes at 70 delta and be something like 15, 16, but then it would increase by 1 point every couple of minutes until you reach exhaustion and theoretically an RPE of 20 within 6 to 12 minutes as an example.
Okay. Yeah, that's a great benchmark to have. So the participants, you gave them instructions before they came into the lab, and those were, the usual: avoiding strenuous exercising, making sure they're fully hydrated, avoiding alcohol and caffeine. I saw, though, that you mentioned they should avoid antibacterial mouthwash. Why would that be?
Well, if you recall when I discussed earlier about the metabolism of nitrate down into nitrite, one of the key reactions that's needed to stimulate that conversion is the oral bacteria in the mouth. So essentially, these bacteria use the nitrate as part of their respiratory chain, and they generate nitrite in return. And if you essentially administer a strong mouthwash, or any mouthwash really, you will kill these bacteria transiently. And there's some nice data suggesting that if you administer nitrate shortly after consuming beetroot, you won't see the increases in plasma nitrite that are necessary to bring about physiological and performance effects. So that's the key reason for asking people to abstain from nitrate for the duration of this study, because it will really interfere with nitrate metabolism.
So if our athletes were to start taking beetroot supplementation, that would be something to consider.
Yes, absolutely. So if you take mouthwash, particularly if you're dealing with very strong mouthwash, like a chlorhexidine containing mouthwash, it will kill off all the bacteria. It's non-selective. Of course, this is a transient effect. It won't kill them forever. They will grow back. But if you're taking mouthwash shortly after taking beetroot juice, then you're not going to be able to metabolize the nitrate as effectively.
Okay. So once you establish the exercise intensities that you would use for the subsequent trials, you had them come in for familiarization visits. What's the purpose of that?
Yeah, so again, particularly if you're dealing with people who aren't highly familiarized with cycling, a lot of the participants in our studies generally are just because most of them are university students, so they're used to cycling on a bike. But severe intensity exercise to exhaustion is still a significant challenge. So we want to make sure that they are familiarized to that, because if you don't familiarize them, essentially what you do is between test 1 and test 2, you will see an improvement, unless you administer a very, very powerful intervention. So we usually want to perform at least one familiarization trial to allow that effect essentially to be massaged out. So we essentially familiarize the participant to the exercise test so that they are accustomed to that and it doesn't then take them by surprise. So we had 2 familiarization sessions where the individuals completed the exercise protocol, including the severe intensity to exhaustion. And we performed this in normoxia and hypoxia to also allow the participants to gain some familiarity with the gas administration apparatus that we used in this study.
Yeah, because that could be quite uncomfortable and it does take a little bit getting used to.
Yeah, severe intensity to exhaustion is quite a tough test. There's worse tests you can do, but it's still hard work.
Yeah, definitely. Not fun. So then they came in for 6 additional visits, and those were the experimental visits. You already briefly mentioned what those conditions were. Could you just recap that for us?
Yes. So essentially what we had is two different clusters of experimental conditions, if you like. So we had the 3 different oxygen concentrations in the gas mixture. So we had normal ambient air, so 20.9% oxygen. This was completed with beetroot and with the placebo juice, which was essentially the beetroot with the nitrate removed. They consumed 3 nitrate-rich shots in all of the trials, and 3 nitrate-depleted shots when they were in the placebo group. So they had that in normoxia. They had the 2 conditions in hypoxia. So I believe it was 14.9% oxygen we used for the hypoxic trials. And they also then repeated that in hyperoxia, which was 40% oxygen. So that gave us our 6 experimental trials.
What would that 14.9% oxygen concentration, what would that correspond to if we were going to altitude? What kind of elevation would that be at?
Yeah, that would be approximately 2,750 meters. So there are places in Colorado or Kenya where you can get that. It's probably on the higher range of where people would go to altitude camps in some scenarios, particularly if you're not very well accustomed to it. So it is a moderate level of altitude. It's not high altitude, but it is a moderate level of altitude.
Do you know what that is in feet for our American listeners?
Oh, yeah, I'm not sure about that.
Me neither. That's okay. They can Google it.
Yeah.
And so we talked about the beetroot supplementation earlier. What was how much nitrates were in those the beetroot?
So when we administered these shots, each of the each of the shots contains around about 400 milligrams of nitrate, or around about 6.3 millimoles of nitrate per shot. And we gave 3 shots in this particular study. So it's either 1200 milligrams or approximately 18.5 to 19 millimoles of nitrate that was consumed 2.5 hours prior to the testing. And the reason that we give this 2.5 hours prior to the testing is that's roughly when we would expect the plasma nitrite to start to peak after nitrate supplementation. And this is quite important with beetroot studies and all studies in nutrition generally, is you need to understand the pharmacokinetics. And because there's basically a second pass metabolism, so you've got nitrate that goes into the system, comes back up to the mouth, and that is then reduced into nitrite. And that then goes back through again through the second pass metabolism. It takes longer than a lot of other supplements to reach peak plasma values. So if you look at something like caffeine, bicarbonate, they might be reaching peak plasma levels within about an hour. Whereas with the nitrate, because it's a second pass metabolism, it seems to take more than double that. So that's just something to bear in mind, is you have to think of the pharmacokinetics. And for nitrate, it seems to be around about 2.5 to 3 hours is typically when the plasma nitrite will start to peak after consuming nitrate supplements.
So 1200 milligrams, that's quite a lot.
Yes.
What's the established amount that is required to elicit some ergogenic effects?
Yeah, so there's a nice dose response paper that was published back in 2013, I believe, where they, in that particular study, and this was part of the work I was involved with when I was down in the University of Exeter, is we at that time gave 1 shot, we gave 2 shots, and we gave 4 shots in separate laboratory visits. It is important to stress that the shots in those days had a bit less nitrate content. They're a bit more concentrated now. So while they now have around about 6.3 to 6.5 millimoles of nitrate per shot, in those days they had about 4.2. But nonetheless, if you think of 1 shot, 2 shots, and 4 shots, to give you a rough guide, what we saw in that study is we didn't see any improvement in exercise capacity with 1 shot. We did see an improvement with 2 shots. And when we administered 4 shots, we didn't see a further improvement in performance. So, but what we found with the economy is the economy seemed to need a higher dose. So acutely, that seemed to need 4 shots of nitrate to bring about a significant effect. So the dose response effects to bring about changes in economy versus performance might be slightly different. So we tried to strike a balance between those two for the current study. So that was the justification for the dose that we administered in the current study.
Do many athletes experience GI distress with that amount?
What you'll find with nitrate is, rather than the GI stress, in my experience, it's just the taste. Some people just do not like the taste of beetroot, and that might mean that they have to drink it very slowly. And I have had some scenarios where 1 or 2 people have been sick, and obviously you have to withdraw them then from the trial, because if they haven't retained the supplement, then you can't test them, because you don't know how much got in and how much was ejected as vomit. So there is a few examples of people who cannot stomach the beetroot juice. But generally, those individuals, if you go to 4 shots, that is quite excessive. And particularly now that they're more concentrated, I would say that you shouldn't really go beyond 2 shots of the Beetroot Sport product. Or if you're using another nitrate product, 800 milligrams is sufficient to bring about effects. If you're not seeing effects with 800 milligrams, it probably means that the person isn't going to respond to the supplement anyway.
Okay, and so 400 milligrams would be in each shot?
Yes, the current Beetroot Sport shots have 400 milligrams per shot, per 70 mils. Yeah.
Yeah, so you manipulated the gas that they were inspiring, and then they completed the step exercise test. Can you walk us through what that is?
Yeah, so basically we had a Douglas bag reservoir, which is a big bag where we typically we use Douglas bags to collect oxygen and expired gases to assess them in exercise. But what we had was a very large Douglas bag reservoir, and what we did is we filled this up with the gases that were confirmed prior to each test. And then we basically fed this into the participants' mouthpiece. So they were continuously breathing this gas mixture, and we were topping this up as the test was going. And that was one of the reasons that we could only use a relatively short duration protocol, is obviously the individuals, particularly when you do high intensity exercise, the ventilation rate goes up. So we had quite a big gas reservoir, but obviously that won't last for that long when people are ventilating at a high rate. So the individuals inhaled this gas for at least 5 minutes. This was necessary to allow the gas to wash into the system and to change the oxygen saturations, for example. The individuals then performed 4 minutes of low intensity baseline exercise at 20 watts. So essentially this is turning the legs around with minimal resistance. They then completed 4 minutes of the moderate intensity exercise, so the intensity below their lactate or gas exchange threshold, and they then completed an immediate transition into the severe intensity work rate, and they completed this for as long as they could maintain. So in terms of the criterion for exhaustion, what we asked the participants to do was to select a pedal cadence between 70 and 90 RPM. And when they cadence, their pedal rate fell more than 10 RPM below the self-selected cadence for more than 5 seconds, the test was terminated and we recorded their time to exhaustion.
Did they know
that gives you,
that
that gives you an overview of the protocol.
Did they know that it was cadence that was being used to determine their limit?
Yes, yeah, we've defined that, and that was defined to them in the incremental test, because we used the same criteria to determine failure in that test as we did in the time to exhaustion. So essentially, they didn't know how long they had been exercising, but they were constantly aware via a dial immediately in front of them of what their cadence was, and they knew as their cadence was starting to fail, and we started to give them encouragement to try and keep their cadence at the required target. And what you essentially see is it's like a dial, it goes up and down around that. People have a little fight with it, and then it gradually wears you down and gets the better. Sometimes people can get one last little push back above it, but yeah, at severe intensity exercise, it becomes quite clear as people become exhausted.
Definitely. And whilst they were doing that, then you're measuring their nitrate concentration?
Yeah,
correct?
So in terms of the blood sampling, we took a blood sample at rest before they started the exercise test. We took a blood sample. So we had a cannula in the vein, so we could sample the blood quite easily then during exercise. So we put the cannula in at rest. We drew a resting blood sample. We drew a blood sample over the last 30 seconds of the low intensity exercise. We took a blood sample at 2 minutes into the severe intensity exercise, and we took a blood sample at the point of exhaustion. And these were spun down so that we could isolate the plasma, and this was then frozen at minus 80 degrees for later assessment of the plasma nitrite concentration.
Okay, and you're measuring their VO2 uptake kinetics, their pulmonary gas exchange as well whilst they were cycling?
Yes, so they were basically had a mouthpiece in during this particular trial, and what we were doing was sampling the expired gases, gas concentrations and gas volume, and this allowed us to calculate oxygen uptake during the exercise on a breath by breath basis. The other thing that we measured in this particular study was we measured muscle oxygenation using near-infrared spectroscopy, and one of the nice elements of this study is that we had 3 assessment sites. So we had 2 on the vastus lateralis and 1 on the rectus femoris. And that, I think, is a nice feature of this study, because what we know is that if you have different sites, even within the same muscle, there is a difference in the oxygenation response, because we have different capillary density, different mitochondrial densities along the muscle. So it's not a uniform physiological representation. So if you have more sites that you're assessing, and obviously more muscle groups, it gives you a greater overall picture of the oxygenation status of the skeletal muscle. And also, cycling is a relatively straightforward exercise. Obviously, the quadriceps are a key prime mover in that type of exercise, so it gives you a good handle there on some of the key muscles that were engaged in turning over the pedals. So we measured that continuously throughout the exercise, and if we averaged the responses then to the 3 sites, then that gave us a more complete profile of tissue oxygenation in the skeletal muscle.
Fascinating. And those 3 muscles were on the quadriceps, is that correct?
Yeah, so we used 2 muscles. So we had 2 sites on the vastus lateralis and 1 site on the rectus femoris.
Okay. Wow. That's a lot going on whilst they're exercising to exhaustion. Yeah.
Yeah, no, it's, I mean, there is, this is the trade-off. Sometimes you want to measure as many physiological variables as you can during exercise to give you some insight. The good thing with this setup is that the participants were able to exercise whilst the measures were being captured. So we didn't have to stop them to take the blood samples because the cannula was in. The near-infrared spectroscopy was continuously placed on the leg, and so they didn't have to worry about that. They had a mouthpiece that was supported by a headpiece to hold the mouthpiece in place. So yes, while the participant was instrumented to an extent, it shouldn't have overall interfered with their performance too much, and they were familiarized with this as well.
Definitely. So what did you find? What were the results?
Okay, yeah, so if we focus on the primary outcome variable first, which was the exercise performance test, what we observed in the current study was that we observed the greatest effect of nitrate supplementation in terms of improving performance compared to the placebo supplement in the hypoxic condition. So this was consistent with the hypothesis that nitrate would bring about the biggest improvement in performance in hypoxia. But what we didn't quite see in this particular project is we didn't see that the performance was different between the normoxic and hyperoxic conditions. And in fact, it was only the hypoxic supplementation trials where performance was significantly improved with the beetroot use. So partial support for our experimental hypothesis.
Okay.
So that was the main, carry on.
Sorry, the performance, that's, you're referring to time till exhaustion?
Time to exhaustion, yeah. So it's a marker of exercise capacity. It's not necessarily a marker of endurance performance directly.
Okay. And do you think what was going on mechanistically there that would improve performance in hypoxia as opposed to, and not in normoxia or hyperoxia?
Yeah, so again, it relates back. The theory is linked to the metabolism of nitrite down into nitric oxide. So in theory, what would have happened, and we obviously confirmed with the muscle oxygenation that the muscle oxygenation was indeed lower in the hypoxic condition, intermediate in the normoxia condition, and greatest in the hyperoxia condition. So we confirmed within the skeletal muscle tissue, the capillary bed that surrounds the tissue, that the oxygenation was lowered in the hypoxic trials. Now, in theory, this would give a greater potential for nitrite to be reduced into nitric oxide in hypoxia compared to normoxia and hyperoxia, and therefore to bring about all those various effects that we discussed previously with nitric oxide. So potentially vasodilation, potentially improvements in muscle excitability, contraction, metabolism. So that's really what we believe was happening there. In terms of the physiological mechanisms, what we also saw is we saw an increase in the end exercise VO2 in the Beetroot hypoxic trial compared to the placebo hypoxic trial. So this suggests that the VO2 peak was elevated in this particular condition. And probably one of the things that caused that response is there might have been more vasodilation within the muscle, which could have allowed more delivery of oxygen to the muscle to allow us to achieve a higher peak VO2 in hypoxia with nitrate. And those effects weren't seen in normoxia or in hyperoxia. And I guess another interesting observation from this particular project was when we looked within the hypoxic condition, what we saw is those individuals whose muscle oxygenation declined the greatest had the greatest improvement in exercise capacity with beetroot juice supplementation. So again, that does support the notion that beetroot is potentially more effective in individuals who have a greater degree of deoxygenation in the skeletal muscle during exercise. So those were the principal findings on the performance and physiological outcome variables.
Wow, okay. And earlier you mentioned the difference between the type 1 and type 2 fibers. Assuming then that different athletes from different sports or different disciplines, would you expect to see beetroot supplementation impact, say, mid-distance athletes more than you would in long-distance athletes?
Yeah, I mean, those types of studies haven't really been done yet. So it is an interesting question. And on the theoretical side of things, yes, you would possibly argue that nitrate supplementation could have maybe more potential to bring about improvements in middle distance performance, given that it's slightly higher intensity than marathon running performance. But again, it really depends on the fitness status. There was a nice study done in Canada a good few years back now. I'm not sure the exact date, but they looked at very well-trained 1,500-meter runners, and they showed on the group mean response that there was no significant improvement with the nitrate supplement. But when you look at the individual responses, there was a couple of the individuals who reported quite meaningful improvements in their 1,500-meter completion time. So again, in theory, it should work better with middle distance type athletes compared to endurance athletes, but it really depends on the fitness status of the individual. And again, that might influence the extent to which they become deoxygenated during exercise. It might influence the pH in the muscle, all factors that can influence nitrate and nitrite metabolism, and therefore the potential benefits that you might experience after nitrate supplementation.
And with that, is there a potential then for well-trained athletes to increase their chances of beetroot supplementation, improving their performance if they're at altitudes? Is that what this study is saying?
Yeah, in theory, it could be that if you take endurance athletes and maybe if they go to an altitude training camp, they might be able to perform slightly more high quality training sessions at altitude. That is certainly a possibility. There has been some studies done with hypoxia and nitrate, and I believe they saw some changes in fiber type expression that were maybe enhanced with nitrate supplementation. But those types of studies, to my knowledge, haven't been done because obviously they're quite difficult. We did a study a few years ago where we took, so the concentration of oxygen that we administered in the current study was kind of moderate to high altitude, getting on towards high altitude. We did a study a few years ago where we wanted to look at lower altitudes where athletes sometimes go to do their higher intensity interval type training sessions, the higher quality work. Because one of the problems with going to altitude is it compromises the quality of the higher intensity training. So they have to come essentially further down the mountain to do those types of sessions. So what we did in a follow-up study to this is we looked at a slightly higher percentage of oxygen compared to 14.9. I believe it was something like 17, 18%. So something that was more equivalent to about 1,250 meters. So what we saw there with better trained individuals is that it didn't improve their performance, again, because they had VO2 peaks in that study of over 60. So again, it's unclear the extent to which this can be beneficial in better trained endurance athletes in normoxia and in hypoxia in particular. But overall, it does seem that they respond less favorably to nitrate supplementation.
Did you see any difference between or any benefit in normoxia in comparison to hypoxia for any of the outcomes?
So one of the main effects we saw with the normoxia is during the lower intensity exercise, the nitrate supplementation increased muscle oxygenation compared to the placebo condition. And that effect was actually greater than in hypoxia. So that was quite an interesting and somewhat unexpected observation in this particular study. So that was the only thing that worked better with the beetroot in normoxia compared to hypoxia.
Okay. So most of your results were in line with your hypothesis?
Yes, most of them, yeah. It's difficult that everything goes exactly the way you'd hypothesize, but yeah, we were able to support the main hypothesis. But also what we have to acknowledge in this particular study is we didn't see an improvement significantly with the beetroot juice in normoxia in terms of time to exhaustion. So again, it suggests maybe that you might need a longer term supplementation period. So we only used an acute serving in this particular project. So whether you need to go with a slightly longer term supplement to go and boost endurance performance, that might be one of the reasons we didn't see effects in that particular element in the study.
Okay. And you mentioned that beetroot juice or nitric oxide has the potential to lower blood pressure or vasodilation, which ultimately causes low blood pressure. Would this be a risk in some athletes that have low blood pressure already?
Yeah, you could make that suggestion, but one of the things with regard to the blood pressure lowering effect is the extent to which nitrate lowers blood pressure seems to be quite closely linked to the baseline blood pressure. So that is, those individuals who already have a low blood pressure, it doesn't seem to be lowered further with nitrate supplementation, whereas those individuals who have a higher blood pressure seem to experience the greatest improvements in blood pressure. Of course, that's looking at blood pressure. We don't know in terms of symptoms of mountain sickness and other things that maybe people experience at altitude. Again, the literature on this is a little bit mixed. There was one study I recall that suggested nitrate supplementation could amplify symptoms of acute mountain sickness, whereas others haven't shown that. So one of the things that athletes probably need to do is try and experiment with this, the first time they go to an altitude camp where they try nitrate, build it up gradually to see how they cope with it and how they feel with it.
Definitely. And then collectively, if we were to look at all of the information together, what does your study say and what doesn't it say?
So I think the primary conclusions from this particular study is that in the population group that we tested, which was young, healthy, recreationally active males, it suggests that an acute serving of nitrate might be more effective at improving exercise capacity, determined as a time to exhaustion, when the muscle oxygenation is lower compared to conditions where muscle oxygenation is higher. And this might have implications for certain exercise settings, such as altitude in certain individuals, or potentially in individuals who have different muscle fiber types, which might experience different oxygenation profiles during exercise. So those are the principal conclusions and potential implications of our findings in this study.
Okay, and if our athletes were interested in trying beetroot supplementation for themselves, are all beetroot, in your experience, is beetroot supplementations, are they created equal, or what would you recommend they look for?
Yes, I think that's an interesting point, and I think there have been some papers published looking at different nitrate supplements, and they've measured the nitrate content. There's Andy Coggan, I believe, is the corresponding author on that, and they did find that there sometimes is some deviation from what is expected in the product and what is actually in the product. And I know for myself in the past, we've measured some nitrate powders or beetroot powders, and they have kind of very little nitrate in them. So you have to be careful when you process things like beetroot, because nitrate is water soluble. So for example, if you were going to make, or if one of your lead readers or listeners wanted to make a spinach dish, for example, and they blanched or boiled the spinach and threw all the water away, there's evidence to suggest that would lower the nitrate content by more than 50%, because nitrate is water soluble and will pass into the water. So the conditions in which the product is produced is quite important. But there are plenty of products out there that do work. There's obviously the Beet It Sport products. There's other beetroot and nitrate powders that do actually contain the nitrate that is expected. And I guess one of the best things for people who are maybe concerned about that is see something that's been published in the literature where it's been proven to increase plasma nitrate and nitrite, and then you know that you're actually using a product that has a true amount of nitrate in there to maybe bring about a beneficial effect. So that is something that the listeners need to be cautious about.
Is it possible to eat enough beetroot or lettuce or rocket to get that amount, the 400 milligrams at least?
It is possible, but it is quite a substantial salad. So you would need to have a big bowl of salad with in excess of 300 grams of spinach, lettuce, rocket, radishes. So certainly possible, but it is quite a big bowl of salad. And as I said, the challenge with that is you don't know exactly how much nitrate is in the salad. You can look at kind of published tables where you can say per 100 grams of spinach, you will get X milligrams of nitrate. But again, that's quite a generic overview, because it depends how the spinach was grown, what time of year it was grown, how much light it had, all of these types of things. So it's I think you can certainly increase, the consumption of green leafy vegetables, and it will increase your nitrate, but the extent to which it increases it and how that relates to the dose that's needed to bring about beneficial effects is difficult to understand. So that's why using things like the Beetroot sports shots or beetroot powders that have a known efficacy to increase plasma nitrate and nitrite is a more controlled way to go about your dietary supplementation strategy with nitrate.
And not to mention, your stomach might be a little bit upset if you were to consume that much before a bite.
Yeah, and it's obviously, as I mentioned, it's quite a substantial meal to have in terms, because again, you'd have to typically have something else with that as well. So it's not the most practical. Whereas, if you think of a Beetroot sports shot, it's 70 milliliters, and even if you don't like the taste, the volume of it isn't too much. So it makes it a little bit more practical as well. But again, there's plenty of products out there that can be used.
Definitely. And so, what else would you like to see studied with regards to nitrates and their performance impacts?
I think, from a personal perspective, I think we still need to understand a little bit more about the mechanism in terms of, well, how is nitrate supplementation bringing about positive effects on whether it be performance, exercise economy. So, the mechanisms for this still aren't fully resolved. So I think that is something that needs to be looked at in a lot more detail. I think there's different types of better trained athletes in different settings. We need to do more in those individuals, and those studies are harder to do because it's harder to do controlled dietary studies in these individuals. So I think those would be key studies. I think understanding the mechanisms a little bit more clearly, and understanding in different population groups, athletes, females obviously is another one that, there's a big call for more research in females to see whether they're different to males and how they metabolize nitrate and how they respond to nitrate supplementation, different ethnicities. So there's quite a lot that still needs to be done to refine the guidelines with nitrate supplementation and what it means for performance. And equally, to understand which settings is it more likely and less likely to be effective in, because if you look at more supplements, if you look at creatine, for example, there's a time and a place where creatine can be useful. So, short duration, repeated sprint type exercise, creatine can certainly be beneficial, resistance exercise performance. But of course, if you give creatine to a marathon runner, you're more likely to compromise their performance. So we need to understand a lot more about nitrate in different exercise settings so we can make more nuanced recommendations and precise recommendations around where athletes might have greater bang for their buck and where actually they might be better advised to focus on other supplements for certain exercise settings.
Yeah, so exciting things to come. Where can our listeners find out more about your work?
So I guess I don't have a huge social media presence, but I am on Twitter. I think, that I tweet about a few things now and again. I'm on something called ResearchGate, which you can follow certain individuals and you can see the papers that they publish. You can also look, PubMed is obviously a very good search engine for us. If anyone wants to find out anything about nitrate exercise, you can type that in and see. Obviously, there's a lot of people doing work in this particular field who they can look up the latest developments in that particular area.
Definitely. Well, thank you so much. This has been a fascinating conversation. We really appreciate your time.
You're welcome, and thank you for having me. I should acknowledge that the study was part of the Masters by Research work of Stuart Coxedge, who's now a PhD student with me here at Loughborough. So I certainly want to give Stuart a big acknowledgement for leading the way with this project.
Great. Well, thank you.
Thank you very much.
Thanks.